You welcome to my YouTube channel once again, Achievers Consult, where science is made easy. In our previous class, we looked at impedance and reactance, and we said reactance is an opposition in an AC circuit, opposition offered to an AC circuit. Then we also say when the opposition is done by an inductor, is called inductive reactance. Then when the opposition to an AC circuit is done by a capacitor, is known as capacitive reactance. Then impedance is an overall opposition to the flow of an AC circuit. And when the overall could be done by a capacitor and an inductor, or a capacitor, inductor and resistor, or a resistor and a capacitor, or a resistor or an inductor. So when is a combination or an overall of a resistor, a capacitor, an inductor, you said impedance has taken place. So impedance is also an opposition to the flow of an AC circuit. But when it's an overall flow, either by an inductor, a capacitor, a resistor, when it's a combination of these, you call it an impedance. Please, if you missed my last class, try and get the video where I taught reactance, inductive reactance, capacitive reactance, and impedance. So today we want to look at AC circuits containing only inductor and capacitor. Definitely, you know there's going to be an impedance here. The impedance is going to be by an inductor and capacitor. Now, AC circuit containing only inductor and capacitor. This is a circuit, an AC circuit. This is the inductor, this is the capacitor. This is symbol for inductor. This is the capacitor. Now, inductor and capacitor series circuit. This is voltage root mean square value and frequency. For inductor and capacitor circuits, the impedance, this symbol for impedance Z, the impedance of inductor and capacitor is given as root mean square voltage over root mean square current, giving us peak voltage over peak current. Now, impedance of inductor and capacitor equals to square root of inductive reactance minus capacitive reactance square. Square root of inductive reactance minus capacitive reactance square equals to inductive reactance minus capacitive reactance. Current in inductor minus capacitance or capacitor, current in inductor minus capacitor, the circuit equals peak current equals peak voltage over square root of inductive reactance minus capacitive reactance square, which is giving us peak voltage over inductive reactance minus capacitive reactance. In inductor and capacitor circuit, the inductor voltage VL and the capacitor voltage VC are out of phase by 180 degrees. Effective voltage then equals square root of inductive voltage minus capacitor voltage or square, which is giving us inductive voltage minus capacitor voltage. Hope I've explained all the French and the strange languages.